protecting your right to do so anonymously. Okay, we're now streaming. Usually I like to start all of my streams by confessing to a felony, but I unfortunately have not done any felonies ever. Okay, so that's good. This is the course website, and it's, is the lighting in here awful? Can you see that?
The lighting in all the rooms in this building suck.
Oh, it's just bad in general?
Yeah.
Okay. Well, I'm just gonna keep showing the slides, but realistically you're gonna use your computer, right? I love computer science because I spent 4 years going to college, and we would all get in a room together and look at our screens and not talk to each other, then close our computers, go home and open them, and then we would keep interacting with each other exactly as much in different buildings. So, no one else likes it when I bring up that's how I went to school. But, okay, so, step 1. I'm going to show you where the course website is. Some of you may have had me before and you know how to do this. I am a narcissist, so every time I type something into a search engine, I start with my name. I have a job. This is true. I have not been fired yet, and that job is at Willamette University. So whenever I am looking for myself, I type Calvin Willamette. And why is that? Because my last name has 5 consecutive consonants, which is too many. Right, so this is Calvin Willamette. Now, Big Willamette University wants you to click this first link. And I can't stop you. Big Calvin Deutschbein wants you to click this second link. And you see, I'm not as good at lobbying as Willamette University, because Willamette's all the way up here. Are any of you using a search engine other than Google? Do you have the same order of links?
You don't even show up.
I don't even show up?
No.
Which one do you use?
DuckDuckGo.
All right. DuckDuckGo. I thought I was okay on DuckDuckGo, so we're going to check. Oh, I'm searching privately. That seems unlikely.
Thank goodness.
Wait, no, I show up. I'm right here.
Your first link shows
Yeah, that's fine.
Your personal website is on.
Ooh, let's look at my Rate My Professor. I taught Data 505? I did a good job. I should be teaching that class instead of this class. Look at this one. It's only 3. A lot of it was... Oh, I'm not beating the allegations. Okay. Okay. So, Big Willamette has me clicking this link. Here's my former cat. She's now retired. I went to my website. Now, okay, so I thought about redesigning this website this summer, right? Because basically all I do is teach, right? So it doesn't really make sense to bury my classes in here, but they're in this tiny little link here called teaching, right? Probably my classes are more important than like Tortuga logic, right? So we click on teaching. Some of you are any of you taking AI 101 this term? I would have seen you in there. You can come hang out if you want. It's fine. It remains to be seen if we'll have a good time or not. So you're taking Systems in C. I know it's not called Systems in C anywhere except on this website. That's fine. I'm going to call it Systems in C. You can call it whatever you want. I think the official name, Sysprogramming, Computer Arc, is unclear. And also I didn't pick it, and also I'm the one teaching the class, so I'm calling it Systems in C. Last year I called it Systems in Rust. Okay, here is one choose your adventure option. If you just want to take this class in Rust, no one is stopping you from finding that class and just taking this class. I will help you exactly as much. All of the lectures are recorded. You can come sit in this class while I'm talking about C and ignore me and watch the videos with your headphones in, and then do the labs at the same time, and I will help you just as much in this class. Rust was crazy easy. I couldn't believe how easy it was to learn last term. So it will probably be almost exactly as hard to teach yourself Rust as it will for me to teach you C. So if you really want to learn Rust for some reason, go ahead and do that, and if you need me to set up an independent study or something. Why am I saying this? It looks like there's jobs in Rust. I think there's jobs in C too. I think they're equally good. That's why I'm alternating years. If you really need to know Rust for some reason, teach yourself Rust and I will help you. I think you should learn C because I learned C and it was super fun. And then I got a job. So that's two good things. So I'm continuing to teach C even though the kids these days all want to learn Rust because it's the cool new thing. What's an example of something that's cool and new? I'm old now, so this is hard. Is anything cool anymore? Yeah, I don't know that there's still cool things. Well, if there were, one of them would be Rust. So, there you go. C is cool in a, like, you know how when you go to parties and sometimes they still play, like, We Will Rock You, even though Queen is 50 years old, and it still hits? That's C, right? Okay. So this is the website. Okay. Apparently I'm going to update the syllabus soon. Oh yeah. I don't know that I really want to say this on the first day of the class. There was, the first time I taught this class, there was some interest among students at this university at having a computer science class that was not necessarily designed to be super easy. So the negation of that. So I was also interested in teaching that class and I thought it'd be good for you. So I put together a class that I think covers the things that are important, by which I mean all of them. This can cause the course to, like, seem difficult at times. I don't think it is unusually difficult, but I think it might seem that way. I've heard from at least one student that some of my classes build character, which is probably true. One of the things that then makes this class somewhat unique is that it's more than one class happening at the same time. Two of the classes that are happening at the same time is a class based on the C programming language, which is commonly the textbook that you would use for your first semester taking a class in the C programming language. Oftentimes, this is a first, second, or third semester class, depending on the type of the university. And usually, if C is your first programming language, they require you to take calculus first, so you have sort of a lot of mathematical maturity coming into it. So it's never really the first class you take, but it might be the first CS class you take. It is now the case that we live in a world in which Python exists, and it doesn't really make sense to not teach people Python. And half the time when I'm writing C, I just write Python that writes C for me anyways. So to me, it makes a lot of sense that many of you know Python, and probably all of you know Python. But it wouldn't be unheard of for a first year to show up here and be like, I'm going to figure out C and just take this class. That happens from time to time. So that's one thing. I spent my time learning C doing sort of assignments that were just designed to teach me the programming language. I thought this was a wasted opportunity. So I have redesigned the classic first semester class in sort of a language like C, so that it all had an application domain. So all of the code we write in this class does something other than just teach you how to program. The other thing it teaches you is cryptography. So this is a C and cryptography class at the same time. This, I hope, feels super interesting to you. This was in response to students saying, oh, it's nice when we have assignments that we can see what we would use them for in the real world. Under absolutely no circumstances should any individual human ever write their own cryptographic code, but you're probably not going to really understand what that code does unless you write it yourself anyways. So this should be immediately useful to you. So I will make some references to this. People have been all over the place on grading. This is screen tearing, by the way, because I don't have the correct fonts installed on my computer. That's what I was going to fix. This is currently flat HTML. Look how disgusting this is. I wrote this HTML by hand because I'm insane. So if it looks bad, that's because no one has ever written their own HTML ever before. I'm the only person who have ever done this. I happen to also think, that in this, I don't know that this is going to make me popular, I happen to think the HTML itself is extremely readable, so I just look at it like this. Don't do that. Or, I mean, you can do whatever you want. One of the design decisions I made, because this class might be difficult, and in fact, the first time I taught it had actually an impossible homework assignment in it. That was unpopular. I've taken it out. It is now possible, okay? It was technically possible if you could run your computer for 1,000,000 years, right? Yeah, so no one liked the impossible homework assignment because, like, oh, we spent a lot of time on it and didn't get the right answer. That's character building. Like, what you were getting out of that assignment was character, okay? Everyone always wants to get the correct answer on the assignment. No, the product we are producing is you. We are making you better at something, or at least feeling better at something. So I've removed the impossible homework assignment, and the plan historically has been you get an A for signing up for this class. I don't like grades. If you want a lower grade, you can ask for one. Someone did ask once. That person's going to get a very good letter of recommendation, right? That's like, you get something back for that, right? The alternative, okay, this is reasonable feedback. Some student said, when you just give everyone an A, I'm not super motivated to do the class. Okay, that is totally fine. That is a you thing. If you feel that way, we can either work out an individual arrangement, so I can grade just you, or reach out to me, and if you want the whole class to go on a quasi-grading system, I have a way that I did do grades for the Rust version of this class. We can apply that. Now, my concern is the C version of the class is hard enough that it doesn't make sense to use that same thing, because I don't want you to all get, like, to do, like, all do really well and then get A minuses instead of A's, right? Just because you're learning C. So think about that carefully. If there is a request, we will conduct a vote on grading policy next class. I'm not expecting a request. And again, this might not come from students. If I find out from my boss that I'm grading this class, then there won't be a vote. I'll just change the policy. And you will be informed of that before the end of ad drop. You should expect to get an A in this class. You should plan to earn an A in this class, and you should be intrinsically motivated to do that. Let me say this. When I took this undergraduate class, I did not check my grades at the end of the semester I took this class. I didn't care. I don't remember what grade I got. To me, it is weird to care about that. It is way cooler to learn C than it is to get a grade. So it just didn't make sense to me. I, like, similarly don't know why there's grades for abstract algebra in the math department. It's like, you're either going to learn it or not, right? Like, a grade is sort of immaterial there. Here's the student learning objectives. I'm going to give a integration lecture on the last day of class that's going to explain how you learned all of these things. I think from a design perspective, so if I were like the director of this class and this were like a theater production, right? The way I would do learning objectives in this class is I would do a dramatic reveal at the end of the semester and you would realize you'd learned all of these things, right? And it'd be very exciting. I put them in the syllabus. This is a spoiler, so don't read this if you don't want spoilers. But it is in there. Don't turn in late work. And you're like, oh, but wait, how does that relate to the grade policy? Okay. I care a lot about student success, and I would like you all to learn things. My sense is you will learn best if when the due date for an assignment happens, you stop spending your minutes on that old assignment and you start spending them on the new assignment. So the due date is set based on when I want you to be thinking about what from a design experience perspective. Now, you can do whatever you want because you're an adult, right? So you can keep working on an old assignment. And there have been occasions where I've seen students like work on something 2 weeks late and feel really good about it. So you should make that decision yourself. I'm advising you against it because I think that's generally a bad idea. You're upper division students. You're going to do the right thing. Just like do what intuitively works for you. I recommend not working on things late. I recommend trying to stay on top of them. On academic honesty, I don't believe it's possible to cheat in this class. It's been a while since I put all of these assignments into ChatGPT and asked them to solve it, but it wasn't close last time. It was much worse than not cheating. So, cheating. It's not cheating because it's allowed, right? So, do whatever you want. There's a bunch of college policies. Okay. I very rarely still include this time commitment thing, and it's now been taken off the Willamette website, so I might have to remove it from my syllabus. In the olden days, a 4-credit hour class at Willamette meets for 3 hours a week, and we get 2 to 3 hours of homework I'm allowed to sign per hour we meet, which means 3 times 2 to 3, which means 6 to 9 hours, which rounds up to 10. So I am giving 10 hours of homework a night, or a week, not a night. That would be awesome. And the way I did that is I made the assignments and I did them myself, and then I assumed it will take you like 4 times longer or something. One of the problems with that is that I think I was like out of practice and I got faster over the course of the semester. So I think the difficulty is slightly backloaded. I have fewer prepared materials than there are weeks of the semester. So I'm going to be monitoring your progress and I will extend a few deadlines, is the plan. I know where the deadlines were extended last time. I think I have solved all the problems, and what we're actually just going to do is hopefully like finish a little early and start watching silent films in class. But we might not do that. So I have a plan. We're going to look at the plan. One other thing might happen to this calendar. By the way, I'm sure you've all noticed this. Did you notice that I managed to name every single lecture title using exactly 6 characters? Do you know how much effort that took? I had to like change what I was teaching in order to do that, which is not the correct thing to be optimizing for. But I had a very, very good time, and I think that's important as well. I hope you can all understand that it is important for me to be having a good time. 2 of these Tuesdays, I have to go somewhere else and give a research talk, I think. And one of the Tuesdays, I'm pretty sure what it is, but the other one I'm not sure. It might move around. And that's like, I think, minimum. I had only ever been asked to give research talks on Mondays and Fridays before this term, so I thought I was going to miss 0 days of class. I was very surprised by this. I was like, oh, I should go to Tuesday, Thursday class so I don't miss any class. No. I don't have guest speakers or anything lined up, so I think I'll just cancel those and it should be fine. Yes.
Is middle assess Calvin 6-character speak for midterm?
Oh, well, it's actually just an assessment in the middle of the term.
Naturally.
Yes. It has a separate 6-letter name, but that would be a spoiler. Yeah. Yeah. And that one's pretty clever, too. Yeah.
If you're already taking photography...
You should do the Rust version of this class.
Okay.
Yeah. That's a very interesting question coming from you. It was interesting to see you here. Welcome to class. I'm glad you're here.
We have to take the major. My major makes me take this class.
You should talk to your advisor about that if you don't want to be here.
here.
I'm aware of this, yeah. I assumed you liked cryptography so much you wanted to take it again.
I will chat with you.
Okay, yeah. You personally should do the Rust class.
Why me personally?
Because Rust is awesome, and we use it in our research group.
I take it.
Okay. Do whatever you want, you're an adult. Okay. And also, if you weren't an adult, you should still do what you want, but I'm not allowed to tell you that, because then I get in trouble with your parents, right? But I was talking to a baby the other day, and I was like, don't listen to them, you're your own person. And the baby was like, I don't know words, but like communicated that non-verbally. Shout out babies. Is there anything else in here that matters? I'm assuming this isn't doing terrible things on your screen, but I'll recompile it eventually. Oh, I have to say this because sometimes people assume it. If there's a religious holiday that falls on a class day, don't come to class, right? You don't have to, you're welcome to tell me. I might worry about you if you're not here, right? But like, that's fine. The lectures are posted. Like, what are we worried about? Okay. Back when I started teaching, I was like, I'm gonna keep track of every religious holiday. That was hard. I was not very good at that. I found out that I was missing holidays from my religion, and then I felt bad. I was like, oh, I shouldn't expect other people to know this, but I don't know it. Okay. Oh, yeah. So probably there's some vague sense within the collective gestalt consciousness of the undergraduate student body, how a Calvin Deutschbein trademark, class website trademark works. Left side is the course level table of contents. Right side is the page level table of contents. These are just the defaults from my website builder. I'm not opinionated about them. I provide a calendar because this structure doesn't always map very well how things are actually working. And today is the 35th of August? What day is it actually?
The 25th.
Okay, that's just a typo, okay. I was like, wow, August is very powerful. Okay, so I'm clicking on a link. I'm going to a lecture. Okay, there are two ways to view a Calvin Deutschbein trademark lecture. I call this blog view because this kind of looks like there's a JFK quote. That's crazy. So why does this view exist? I used to only provide, I'm clicking on right-hand side, other formats, reveal.js. This is slides. So back in the olden days, I used to teach on a whiteboard with my handwriting, and no one could read it. And I felt bad. So now I make slides. I happen to really like my slides, so this is an upside for me. It's sort of like being an artist. Okay, so there's this view, but at the end of one of my semesters where I was teaching, I was watching a student write a script that scrolled through the slides, took a picture of every single one of them, downloaded them as images, and saved them as a PDF file of images. I don't know why someone would do this. This is not how I view things, anything. But I thought it was extremely ugly. So I took my source code and I just compiled it into an HTML web page. There is something pretty cool about this, which is you can like use Control F on the whole page. So you can like look for systems. And then you can separately use this thing here and look for systems on the website. Now, if your Wi-Fi turns off, this search bar is going to a remote server, so it'll stop working, but that's okay. So I'm providing this view as well. I just taught another class with a Calvin Deutschbein TM course website, and I was walking around that class, and it was like very close to 50-50 whether students were using the slide view or the blog view. So I don't know what you'll prefer on providing both. I'm going to teach off of the slide view because I think it makes better videos. This is a zero indexed class, so we are day 0 of week 0 right now. Logistics. Okay, I'm starting the course now because I think I've got us far enough in. We can all follow along. I'm going to exaggerate. Is it 100 billion degrees in here?
Yes.
Okay, just making sure. Okay, welcome to Computing Security, or Systems in C, or whatever. It's the Voltron course. 2 years ago, I looked at what the accreditation standards were for a computer science degree in an engineering college. This is not making any claims about the relative value of an engineering college or not. I was simply curious. I was pretty sure I could fit everything we were missing in 4 credit hours, and that's where this course came from. Go to the course webpage. Oh, join the Discord. Are you all in the computer science? No, it's a different name. Is there someone in here? It's like Woo Tech Club now or something, right? Do any of you know?
Willamette Student Technology Club.
Okay, so I think, I'm not sure about this. The problem with the Willamette Student Technology Club, there's some people in there that really like computers, right? And some of you might be here to just like learn or take classes or like just be academically interested in computers. And so, I think it's a good idea for this class to be a subject area within the student association. The competing formulation is you can get your own Discord if you want one. Just think about that, and then on Thursday we'll make a decision. I will send out the appropriate link. We will all join it, and then you'll have a way to send me direct messages if you don't already, right? There is an orthogonal benefit to Discord. Some of you, I am your advisor, and some of you may have asked me advising questions in an unofficial capacity. That seems to work really well over Discord because I can like send you a screenshot of something, so it's like a nice format for that. So getting you all a way to talk to me on Discord, I think is useful for advising, even if it's not useful for this class. So it's something I like to do. If you somehow don't have a GitHub account, that is on you. If you need help, I will help you. Let's see if that date's correct, because I think it is. Yeah, that's September 3. Okay. Everyone, without exception, loves the Enigma assignment in Computer Science 151. It is universally, I'm making strong claims, it is universally everyone's favorite assignment. This is true, right? Can I get some nodding heads? Wow, some of you are actually nodding. You don't have to listen to me. Okay. So the first assignment is to do Enigma in C. Why is that? Well, the rule of thumb, unclear if this is still true. I'm persuaded it's still true. The only real way to learn a programming language is to just do something in it. You already know how to do Enigma. And I know what you're thinking. Some of you are thinking, well, I didn't do Enigma in CS 151. Fantastic, you get to learn more, right? So there's no bad outcomes here. The purpose of getting Enigma to work is this is a cryptography class taught in C, so you're doing cryptography in C. It's like, it's the warm-up assignment. I don't know how well any of you remember Enigma, but basically, you have a cipher, which is a substitution cipher. A substitution cipher is the 26 Latin characters in order. It is an ordered data structure. You can think of it as an array. You apply this cipher to a phrase by taking the letters in the phrase, taking their position in the alphabet, and substituting the letter at that index in the array. You do this iteratively 7 times. Each letter in your original plain text causes you to rotate one of the ciphers, which is just changing what the replacement is by 1 index. This is described on the assignment website. It has also been covered in CS 151, so I'm not going to dwell on it too much. I have some graphics and visuals on there. We have lab time on Thursday if you are not like super vibing with Enigma. The way to tell if your Enigma machine works correctly is it is a symmetrical cipher, which means if you put a secret in it and encrypt it, then you put that encrypted secret back in, you get the original secret back. So it's reversible. So put in some text, and then put that text in again, and you should get back the original text. That means it works. Okay, I'm going to introduce the course. Oh, there's tools we're going to use. Okay. When I say if you are afraid of the command line, drop this class, I don't mean that. I mean take this class so you're not afraid of the command line. Okay? That was mean. I shouldn't have said that. That was tired Calvin wrote that line. I am currently happy Calvin, right? Happy Calvin wants you to learn and will help you with the command line, right? Tired Calvin is in trouble for saying that. Bad. Okay. These things are commands at the command line. Are they really? Oh, what is that? That's my display settings. Podman. Oh, look, it's a command. What was the other one? Vim. Ooh, look, it's exciting. GCC. It's a command at the command line. Git. It's a command at the command line. Have you used the command line before at all? Okay. That's good. Okay. I'm going to introduce myself. This is incomprehensible. You don't have to try to say my last name. Oh, I remember the story here. Okay. My graduate, not my undergraduate, my graduate advisor was Professor Cynthia Sturton. And you note I say Professor Cynthia Sturton. We bring that up because I'm doing names. Professor Cynthia Sturton likes to be called Cynthia. Professor Cynthia Sturton says this to undergraduate students and notices that none of them ever refer to her by name. They just kind of like point or say like, hello. The theory is, we don't know, we can't check this. Some students are apprehensive about referring to professors by their first name. Professor Cynthia Sturton has a pronounceable last name, Sturton. I do not have a pronounceable last name, so I am having to solve this in a unique way. I suspect you want to refer to me as either Professor Calvin or Calvin, depending on how you feel about things. I am not going to be offended by how you refer to me. I'm not going to be offended if you say my last name in a strange way. So do whatever you want. I would like you to feel comfortable referring to me so I know who you're talking to. I've been called pretty weird things that I didn't find offensive. I think, was it like, there was like the big C. Is that yeah. That sounds like a body of water to me. That's totally fine. I like bodies of water. I use they, them pronouns, which I always forget to tell people and just assume they'll know and use it, so now you know. The work of this class is loosely inspired by my doctoral thesis, in the sense that I was convinced of certain things about computer science while working on my doctoral thesis. The work of my doctoral thesis is not relevant to this class, but the person I became while working on my doctoral thesis is relevant to this class. I found the experience of working on those projects personally empowering, and I've tried to package that up in a more digestible serving for you as undergraduate students, so you can have the same level of empowerment without going to school for 6 years. But I'm going to introduce my thesis regardless because I think this might be interesting. I claim there are bugs in software. Software does not always work. I can give an example. Some of you have navigated to our course website and attempted to open the syllabus and noticed this, which is really ugly and bad. I would call that a bug in software. Hardware is more expensive materially than software. To actually create physical computer hardware, there has to be a factory somewhere, there has to be materials coming into the factory. All of these things are expensive, people have to work in the factory. It is very different from software, which is frequently just text that someone runs some program on, right? What this means is that if you find a bug in hardware, it costs a lot of money, because it is more expensive to make new hardware than it is to change software. By changing some text, you might have to go back and you might have to change your factory. It was thought for many years that there couldn't be bugs in hardware, and then someone found some, and now it's a problem. So my work in graduate school was to prevent that from happening again. When I was doing that, or when I was doing anything else in computers, or like writing a grocery list, or deciding how to drive somewhere, I'm like running ultra marathons now, and I like solve the problem. Like, I think I had heat exhaustion on Saturday, and I like solved the problem the same way I solve coding problems. Just like everything I do in my life, I solve the same way now. And I do it with one of two things: pointers and recursion. I think you all know what recursion is, right? Very simple to explain in one sentence. To understand recursion, you must first understand recursion, right? It is not required that you have taken Math 251W, Foundations of Advanced Math, before this class. If you have, you've learned induction in that class, which is a similar style of thinking. Those classes go well together. If you take that class first, this class is easier. If you take this class first, that class is easier. So they work well together. So I claim that recursion isn't too bad, but that we probably haven't used it enough, and we probably haven't seen how powerful it is at this point in our undergraduate career. Some of you may have implemented a recursive data structure in CS 152. Do you all know what a linked list is? So that is an example of recursive data structure. There is swirling rumors around the computer science education community that we shouldn't teach linked lists anymore because they're slow. So I'm not going to teach you linked lists. I'm going to teach you blockchain, which is a linked list called a blockchain. That's the difference between linked lists and blockchains. So I claim recursion is not that bad, but that we haven't done enough of it. I'm going to claim that pointers are darn near the hardest thing there is. I just tried to verbally explain how Enigma works. Do you remember that? That was awful. I was like, okay, you find a letter and you compute its index in the alphabet, then you look in an array at the index that corresponds to the index of the letter in the other array, and the value you find at that index in the second array. See, this is non-trivial. I'd argue that just like fundamentally, like English is missing the vocabulary to correctly describe this. Not to worry, I'm teaching this class in a different language, C, which has the exact language we need to describe it. Here's something that I find obnoxious about Python. I don't like that the type of a variable changes how the variable works. So if I take the name x and I assign x to hold the value 1, then I write a function that adds something to x. Wait, does plus equal work in Python?
Yes.
Okay. If I try to run this function, I can't refer to the value x, which would suggest to me I can never refer to the value of a variable that is defined outside of the scope of a function. That's what it would suggest to me. But I can change the type of x. And instead of x being an integer, I can instead make x a singleton list. And that singleton list can contain an integer. Then I can write a new function where I do the same operation on the integer part of x. So I look at x, I look inside x and find the 0th element of x, and I add 1 to that integer. and for some reason, I no longer get an error message, and now the value of x can change. This does not make sense to me. I do not know why, by changing the type of a variable, I change whether it can be referred to by a function or not. Now, I understand why this is happening, and it makes perfect sense to me because I know the C programming language. So part of the pitch here is that you're going to run into weird things in non-C programming languages until you understand them in the C programming language. The C programming language is not necessarily a language that is particularly useful for you to write code in for the rest of your life, but it is a way of describing what computers do that is useful to know. Separately, there are jobs in C, but you're probably also better at getting a job in Java if you know C. In Python, an integer is a literal value, and a list is a description of a location. Functions are allowed to go to other locations and change values there, but they cannot change literals because literals have some fixed value. This is easier to describe in C than in English. A pointer is a variable, but it is not a variable that stores a value. It is a variable that stores a way to access a value. There's one level of misdirection. This one level of misdirection is what allowed us to avoid our runtime error in Python, and it is what allows you to do things like have variable-sized data structures. It's pretty powerful. I think of recursion predominantly with regard to functions that call themselves. When I was taking my version of CS 151, I did not learn about for and while statements. I took the entire class recursively. I wrote all of my code recursively. I didn't write any loops. That was awesome. I still don't trust loops. Loops keep having off by one errors in them. With recursion, you explicitly write a base case. It is more verbose. It is traditionally less efficient. In the Rust programming language, I teach recursion because the compiler in that language can handle it. Usually recursive code in practice is lower performance for various reasons. But recursion is very powerful. You know a little bit about algorithms because you've seen them in other classes, and there is also another class at this university called algorithms. This is not an algorithms class. This class is intended to bridge the gap from understanding the theory behind how fast an algorithm can be to the practice of how we actually get the lightning that we trapped in the rock that we taught how to think to run the algorithm. There's also another term here. Excuse me. My throat hurts. Memory management. Within a computer, all of the values that are stored within the computer exist somewhere in memory. And when we write Python, the Python interpreter just puts things in memory where it wants to. This is often good enough for many purposes. For high-performance code, such as code that is in an automobile, or a smart device that is doing distributed agriculture edge computing, which is a common application now. There are cases in which performance matters a lot, both in terms of speed and in terms of predictability. When we need these things, we have to intentionally manage memory, decide what physical locations in a solid-state drive or a hard drive are going to correspond to what information. With the C programming language, we have the granularity to define those things, and with Python, we lack the granularity to define those things. So we're going to get a deeper control of our computing device. It is going to require us to be more thoughtful when we're working with our computer device, but it's going to enable us to do more with our computing device. So, here are some other languages that I am not teaching this term. I am not teaching Python, though I will use Python. the same way I'm using C, as a dialect to explain concepts. I believe I provide, for example, an Enigma solution in Python. And it does not work for the CS151 assignment, so I'm not giving you a solution to that, because it doesn't use objects. So it would score 0 points in CS151, you can still run the code and test it. I hope you enjoy this. Enjoy running Python code, it's great fun. There exists JavaScript, Java, C#, C++. I think you've heard of these. There's nothing wrong with these languages. These languages all share a common weakness. None of them allow you to talk about memory directly. And that is not true in the case of C++, but C++ is designed so you don't have to talk about memory directly. So if I were to teach C++, I would actually teach the exact same class I'm teaching right now. I would just always say C++ instead of C. And then I would say, this isn't really how people write C++. So I'm just not doing that, I'm just saying C instead. These languages all have part of the design of the language that is going to take care of memory for you. This is good if you don't want to think about memory, and it is bad for this class because this class is about memory. So, I claim this lack of clarity will adversely impact your education if I attempt to teach these low-level concepts in those languages. If you are working in a low-level setting, so embedded computing, robotics, automotive, aerospace, safety critical, human rated, radiation hardened, power systems, and all these applications, which is not an app, a website, a game, you would benefit from having the additional work that goes into writing high-quality C code. I also claim, and this is mostly true, that if you're doing anything where performance matters at all, you cannot use these other languages. Some people have pushed Java pretty far in very specific circumstances. Java runs on something called the Java Virtual Machine that is written in C. So that's unsurprising to me. I claim these are good languages except for Java, but not for us. I don't really think that. I think the good languages are Lisp, Python, and C and nothing else. But I'm trying to get along with people. So yes, C# is a great language. Go learn C#. Okay. I write a lot of JavaScript. And I don't care that I think it's a bad language. It's great. It's a guilty pleasure. It's like crossing the street without looking both ways. It's like, oh, that feels great. Okay. Why am I teaching this class in C? I've told you a little bit about this. In CS education, the move away from C was caused, I think, by humans in general have a preference to do things that are easier than things that are harder. This is good. It's like a good bias to have. C is not the easiest way to do anything. It was invented to be an easier way than something that's harder than C. And then because C exists, a bunch of easier things now exist. That's how we start. If you only ever do easy things, you don't get better at doing things. So, we teach this class in C so you get better at something. It was difficult to conduct research in my research group without having students that knew C. So it was like immediately obvious to me what you can't do if you don't know C. And you can do all of this without ever actually writing C. Here is a blog post from 2001 about programming languages that you can read if you are more curious about this. I thought this was an interesting article. I will summarize the thesis briefly. Virtually everyone that learns programming thinks the first language they learn is the best language because that language precisely handles all of the things that they don't know about and then has all of the built-in features that they want. And it seems like every other language to them should have the exact same set of features because that's what they're used to programming with. I think it is important as a computer science educator to make sure that even if you think that, you are aware that those are the cognitive biases going on behind something. It is great Many of you probably love Python. I don't know, are big Python fans? Big enough Python fans? Yeah. I'm a big Python fan. I think like no one ever believes me when I say this because I talk about how bad Python is all the time. I think it's bad compared to C, right? I don't think it's like bad compared to ice cream, right? It's much better than ice cream. And so, especially my first few years at this university, I believed we were sending students into job interviews, and they were frequently saying that like either Python or R was like the only language you could do for anything, and there was like no reason to use anything else, and like there weren't a ton of jobs in Python and R. This article is a helpful way to think about this. Thinking and talking about programming languages is like fun and interesting, but it is often sort of besides the point. When you graduate with a computer science degree, my hope is that you do not perceive the programming language you are working in. You are simply thinking, expressing those thoughts in text, and you happen to make some decision about how you express those thoughts in text. Oh, my throat's getting cooked, folks. I don't know what to do. Fun fact, Kennedy is my middle name. We don't believe we're related to those Kennedys. Since I made this slide, the Kennedy name has become increasingly in the news in ways that are perhaps unpopular. Don't blame me, I voted for redacted. I love doing things because they are hard. And you can also learn to love doing that by taking this class. Okay. I really like how clear C is about what is going on in the computer. I just feel like, you know how in Python you don't have to write return at the end of your functions, but you can? That just makes me uneasy, right? Like, I understand why you would do it, right? Like, I've written a lot of code, and it is very convenient to not have to write return every time. I understand that, right? But it feels like you should have to, right? I don't necessarily like the idea that when you create a list in Python, you don't have to think about how many elements it's going to hold. I think you should think about that. I think that should matter to you. I think that should be important to you. Not always, but sometimes. And I think this matters a lot when you're doing security applications and you have to be very, very precise about whether your credit card information is kept safe or not, right? I just fundamentally don't want to do that in Python because the language it's too loose, it's too free. There's too many ways things can escape it. So C has fine-grained control over memory, and you can write in operating systems in it. You are probably all aware we don't have a security course here. So I'm embedding the security course in this course. I think that makes this course more interesting. Your mileage may vary, just tell me what you think at the end of the term. I was excited about this course, I found it interesting. I've done all of the assignments myself. So I took this course from myself. And I thought it was awesome. So, okay, here's your spoilers. I don't necessarily feel a need to go over all of this right now. When you're done with this class, you will have earned a computer science degree, basically. Okay. Here's the course sketch and how. Can you see those? This is hard to see, right? Okay. So here's the flowchart for this class. We're starting here with no prior knowledge. From the prior knowledge of one year of Python, which is I'm assuming. With 1 year of Python, I can teach you SHA and RSA. These are both cryptographic algorithms. SHA stands for secure hashing algorithm. I believe you know what hashing is because I believe you've been taught hash tables. If you haven't, I will teach you what hashing is. It's turning something into a number. There, that was easy. RSA is three people's name. Rivest Shamir Adelson, I think. It is an algorithm named after these people. What it allows you to do is, over an unsecure network, you can exchange numbers, and then you can communicate with encrypted traffic over that network, and no one except you can read it. This is very cool. This is why you can buy things with your credit card on the internet. When I was in 3rd grade, I remember the first time someone in my class bought something on the internet, and we were sure they were crazy and they were going to have all of their money stolen. And then we were like, wait a minute, aren't telephones pretty insecure too? Anyways, at some point in time, people, especially in the United States, got convinced they could spend money on the internet, and that's the entire economy now. I think there's just Amazon trucks everywhere. It's crazy. Okay, so you're going to learn SHA and RSA. These are mathematically cool, and they're good assignments. With the benefit of the secure hashing algorithm, you can make a blockchain. A blockchain is a linked list that is hashed, so you can tell if someone is fidgeting with it. After you learn RSA and SHA, you can create a Merkle tree. A Merkle tree is the tree data structure, but it also has hashes in it. So, we're going to learn cryptography, and then we're going to learn cryptographic data structures. And then from there, we are going to implement Bitcoin. People were really into Bitcoin 24 months ago, and I was like, it's not going to be cool in 24 months. And they're like, make a class about Bitcoin, make a class about Bitcoin. I tricked them all. I made systems in C and just told them it was a Bitcoin class. Now that Bitcoin's not in the news anymore, it's not super cringe to talk about, and we can just understand it's this cool computer science thing, which is how I was learning about it. I read the Bitcoin paper in a class in 2012, and we're like, good thing no one's ever going to think that this is real money, right? I think we're just back to that. Okay. And then the Bitcoin thing is the sort of capstone final project for this class. Okay. I want to explain these a little bit. SHA, among other things. It's a command at the command line. I don't remember how it works. Wait, do I have any files? SHA 256, Was I downloading images of Carolus Linnaeus? I had to, it's a botanist, right? Okay. Here's the textbook for Data 505. Apparently, I wrote a recommendation letter for a unit. Oh, here's malloc.rs, okay. So, SHA is a cryptographic hash function family. What does it do? It takes a file name. Here is apparently I'm not a coward. Here's some Rust code if you want to take the Rust version of this class. So I take a file, I apply the secure hash algorithm function to it, and what happens is I get back a fixed size hash value. What does this mean? So, when I compute the hash of malloc.rs, I get a number this big. How big is malloc.rs? Let's word count it. It is okay if you don't know what the command line is doing yet. We're exposing you. You don't have to be able to do this at home. This is an extended demonstration. There's 96 lines, 409 words, and 2,543 characters in malloc.rs. I thought I had some some images in here. This image is way bigger than my text file. It is this much divided by this much bigger. Can I get that? This image is 867.3 times bigger. But if I SHA 256 sum the image, I'm going to get a hash of the same size. We see that this is the same number of characters. These characters are hexadecimal, representing a numeric value that is 256 bits in length. What is the usefulness of this? I post a download link to an operating system. The example is always the Linux operating system. I am using Linux on my device. I will respect you more if you use Linux on your device. We can't get Linux gracefully running on Mac devices, and we expect everyone to be using Mac laptops because for some reason only Macintosh can make good laptops now. No one knows how this happened. I wish you could all use Linux, and I also wish that you all had Mac laptops. I can't have both of those things. I am using Linux so that minimally you will see Linux, and you can put Linux on your resume. Okay, now, the way I got Linux to be installed on this Willamette University administered computer that I do not have permissions to install Linux on is I downloaded a file from the internet. I saved that file to my hard drive. I pressed the power button and some other buttons at the same time, and the computer came back to life with Linux on it, and I did not tell WITS. And if I did, they'd just think it's really cool and pretend they didn't hear me, right? Do any of you work for WITS? I should have asked that first. So, I'm recording this lecture. I stop at every stop sign. I have never rolled through a stop sign. Okay. Before I turned off my computer and pressed and held down a certain combination of buttons that caused my computer to wake back up as Linux instead of Windows, I made sure I accidentally didn't download a Bitcoin miner that was going to take over this computer, burn my GPU. I actually bought a good GPU for this because I was going to teach machine learning, which I guess I kind of do. I made sure I actually had Linux. And the way I made sure I actually had Linux is I typed SHA 256 sum, whatever the name of my Linux file was. And I looked at the relatively small number of characters. We have an aside where I'm going to do mental math. I believe you should all know how to do math, so I'm going to model some thinking for you. An SHA 256 sum is 256 bits in length. A bit is a 0 or 1. It is represented as a hexadecimal string. A hexadecimal digit represents up to 4 bits because there are 16 hexadecimal digits, 0 through 9, and A through F. What this means is that we can have one hexadecimal digit represent 4 bits. So if we have 256 bits, how many hexadecimal digits do we need to represent the value? It's 256 divided by 4, which is approximately, well, it's exactly 64. It is good to be able to recognize these powers of 2 when they occur naturally because they show up a lot in systems computing. So, I only had to look at 64 characters to tell if an entire operating system that can cause my Wi-Fi router to work, that can cause my keyboard to work, that can correctly monitor the battery usage of my computer, that can enable me to install and play video games on my device, though I would never do that because I only use my device for work, and crossword puzzles, which I run in my browser. So, I did all these things. I looked at the 64 characters. I verified that the 64 characters were the same. Now, I know what you're thinking. You're thinking, oh, wait, I don't know what you're thinking. What are you thinking?
The same as what?
The same as the 64 characters provided by the people that posted the Linux file on the internet. So, they post the operating system, they say, when you hash it, you will get this number back. Now, is this perfect? Of course not. Because someone could be impersonating the Linux website. But it is a step towards security. So, I computed my sum, the Linux people computed their sum, I verified they were the same, and I verified this on a website I trusted. That's about as good as you can do. I know it worked because when I touch this device right now, it's not hot enough to be mining Bitcoin, which means it's not doing something against the rules. and I'm running a lot on here right now, so not too expensive to show slideshows, right? Well, this isn't actually optimized slideshow software. I'm displaying this slideshow in a browser, right? So there's JavaScript running. JavaScript's a fine language, but it's much less efficient than C, so it's taking a lot of energy to do that. The JavaScript is doing graphics tasks because it's defining what all the pixels on the screen looks like. While it's doing that in the background, I'm screen recording. So someone's still capturing all of those pixels as well. Pixels are way more expensive than text, right? I'm saving images. I'm saving an image 15 times a second. Now, I can compress the images quite a bit because usually the images aren't changing, right? But I can't compress the sound. I'm also recording sound, right? Sound's probably not as dense as image, but there's sort of a lot of bits running through my computer every moment in time, right? So there's a little bit of heat, but not too bad. Okay, so I have my operating system. I verify that it's correct. I turn my computer back on, and it works amicably. And I could not have had confidence to do that unless I could compute the checksum, this SHA hashing out. So this is a nice feature. This is something that the internet runs on. I suspect you are thinking, well, I've never checked a checksum. Of course you haven't. Firefox or Chrome is doing it all the time without telling you. Sometimes you see something that says, hey, this certificate expires. That is correct. You should be stressed out about that, but not that stressed out about it, right? It's a problem. RSA is really cool. There's an exciting lecture coming up this term where I'm going to talk a little bit about some of the sociological implications of cryptography and systems computing. I'm going to use the motivating example of the Snowden disclosures, and I'm going to talk a little bit about journalism. I think it's difficult to understand the mechanics of how sensitive information about the actions that a government was doing without having some appreciation for the underlying cryptography. I think it's an exciting way to understand something that is historically significant that happened. There is also one core insight that comes from RSA, and I was motivated to teach RSA specifically in a systems computing class for this reason, because I have taught it in non-systems classes, and there is a point that is hard to get across. In a computer, it is infinity times harder to divide numbers than multiply them together. It may be non-obvious why this is. Do not worry, I am going to give you a programming assignment where I make you write a division algorithm. And it will be so horrendously difficult, it will not matter if you complete the assignment or not. You will never again forget how painful it is for computers to divide numbers. It is so easy to add numbers, you will not understand why you're doing the assignment. You will do multiplication and be like, that wasn't that bad. And then you will wonder if it has ever been possible to do division. Like, what even is division? I remember, slicing a piece of cake at my birthday party growing up and being able to get exactly 8 slices, but now I have no idea how I ever did that, right? And it gets worse, because what's really hard if division is hard? Telling if numbers are prime. I was giving an AI 101 lecture this morning, and for some reason the number 37 came up. Intuitively, my mind immediately went, 37 is a prime number. Do you know how hard it is to check if 37 is a prime number if you can't do division? It's impossible. 37 is 2 digits long in decimal, and I can fit it in 6 bits. It is not a big number. It is impossible to tell if 37 is prime, because it is so hard to do division. RSA relies on 4,096-bit prime numbers. Anyways, I calculated it would take the code I wrote would have taken my computer 10 million years to determine if a 496-bit prime was prime or not. It couldn't do it. And I was pretty proud of that code. It was pretty good code. It is true that it happened to explode if there were 64 0 bits in a row, which occurs at probability 1 and 2 to the 64th. I know what you're thinking. That's pretty low probability. Not if you run your computer for 10 million years. So I was hitting the corner case. Okay. The way this works is I have my prime number. I take my secret, I store my secret as bits, I multiply my secret by the prime number, and the way you get my secret back is you divide by the prime number. But division's impossible. So what I do instead is I held on to another secret prime number that's easier to divide by. And the way I divide by it is actually I multiply it by something because it's possible to multiply. So I have two numbers I can multiply together to get back the original number. This works because of modular arithmetic. It is a super cool lecture. I look forward to giving it to you, and I think you'll appreciate it. Now, in the Rust version of this class, I do not teach RSA anymore because RSA is not used anymore because of something called timing side channel attacks that I will teach you about in your doctoral program when you join my research group at a research university that I don't currently teach at. So RSA is not used anymore. I looked into what replaced it, and I didn't think it was as worthwhile to teach. But if you are very curious, the lectures in Rust are available. You should go to grad school. Okay. Once you have written RSA and SHA, you can implement blockchain. Or that's not true. You only need SHA for blockchain. For all of Bitcoin, you need the other thing. And why is that? RSA tells you who owns a thing, and so it preserves the secret between people. And SHA tells you that no one fiddled with the list of who owns what. This is also going to teach you a very valuable security lesson, which is the difference between confidentiality and integrity. Last time I taught this class, one student did nothing but take this class and then tried to get a security certification and passed the security certification exam on the first try. I am not teaching security. You are going to happen to learn security during this class, and you will be able to get the Security Plus certification, which is somewhat valuable. It's mostly valuable for our students.
How's that ask us if we have valuable?
So I think if you've been out of work for 3 months after graduating, you should go out and get it and see if it pushes you over the edge. And if you're looking for something to do, I think it's not that expensive to get. I think the real benefit is if you walk into a job interview with someone that knows something, you're going to happen to say combinations of words that are going to cause them to believe you know what you're talking about, right? And you will, like, you're not faking that, right? So you're just going to be like a better, more well-rounded, and more conscientious computer scientist. And incidentally, this means you could get the certificate, right? Blockchain is on. Oh, right. I didn't point out the last thing. Once you have the cryptographic algorithms, you can implement blockchain, but you would be able to implement it in a high-level language without thinking about memory. When I first taught this class, it was extremely convenient that we had spring break right into the middle of the semester, and so I taught no memory in the first half, and I taught yes memory in the second half. This semester, we're just going to randomly start talking about memory at some day. It's going to be less graceful. But when I do that, we're going to learn a little bit more about linked lists. We're going to look at linked lists in a low-level language. Linked lists alone are interesting, but I think you can accidentally write a linked list correctly without understanding what you are doing. They are a little bit too easy. And I do not think trees are too easy. They might be, not sure. But I feel pretty good about you being able to deal with pointers and recursion once you make a recursive data structure out of pointers. And it is a non-primitive data structure in the sense that there is more than one pointer, so there's a branching effect. The Merkle tree in blockchain stores the list of transactions that occurred at a given time. It is weird to say list, it's kind of an array. Separately, Merkle trees have a really nice symmetry to them, which means we can store something that has the shape of a tree in a memory region that looks like an array. I think this is an important learning insight, and I am eager to show it to you. Once you've done all of that for your final in this class, it will be a final project. I'm going to ask for you to implement Bitcoin. It's going to be pretty cool. Don't use your own Bitcoin.
Can you repeat that? We're going to do what with Bitcoin?
You're gonna implement Bitcoin, but you're not going to have any Bitcoins.
Okay.
if I can't give you a Bitcoin because the only thing you can do with Bitcoin is felony, right? And I know what you're thinking. You're thinking, no, I can trade them on the New York Stock Exchange. That's securities fraud. That's still a felony. Okay. By my count, we have 5 minutes of class left. Does that sound correct?
Yes.
Very good. We will resume this Thursday. I am letting you leave 5 minutes early. Do not be loud, because I don't want other classes to be upset that you're getting out early. So please be quiet and respectful. Come talk to me if you have any questions. Also, if you do strength, resistance, or weight training on this campus, please come talk to me and explain how do you do that. I can't figure out how to do it, and I'm curious.